So another sampling distribution problem. I know that I know these things have normal distributions, even though the commercial age, now here's the difference, even though the commercial age aircraft are normally distributed, we know that the sampling distribution will also be normally distributed. So what they're doing here is, this is back just the normal curve. So I'm talking about an individual aircraft. So we don't need to do anything fancy with this. We just need to decide on, let's see, the mean is 13. We want to know what percentage of aircraft have a standard deviation, what percentage of aircraft last longer than 15 years, or an age greater than 15 years. So one way to do this is to get a z-score. So we're going to do 15 minus 13 divided by the standard deviation is 7.1. So when I did that, I got 0.28. And then if you look that up on that normal curve table, Appendix A in the book, or whatever table you're using. So I took a picture of that table. So 0.28 is 0.2. I'm going to go over to the 0.8 column. Alright, so that's telling me that 0.6, so this blue area is 0.6103, and if you remember, my sketch from before was to the right, because I want to know greater than 15 years, I have to do 1 minus that. And that's where I get the probability, or I could change that to percentage and find out the percentage of aircraft that last longer than 15 years. Now for the second part, what happens when we have a sample of 49 aircraft? There's going to be a lot less variation. So to get that new standard deviation, because now it's a sampling distribution situation, I'm going to take my standard deviation with a population of 7.1 and divide that by the square root of 49. I got, let's see, 1.014 for the new standard deviation. Now to do this by hand, we're going to do the same thing. We're going to find the z-score. So 15 minus 13, but then I've got to divide by this new standard deviation. That's giving me a z-score of 1.97. So now if I go back to that table, if it'll let me, if I can read it with all my writing here, let's see, 1.97. Let's see, so 1.9, and I'm going to go over to the 0.07 column, and I'm seeing 0.9618, I think. Yeah, no, is that the right column? No. 0.97, yeah, I got to draw a line. .9756, right? That's the 0.07 column. So this area to the left now, here, let me clean this up. So we know that area to the left is 0.9756, and we want to know this area to the right, so we would do 1 minus 0.9756, and it's going to be a much smaller percentage, right? A much smaller value, and we would expect that because the sampling distributions vary a lot less than the population distributions. So I hope that helps.